I am in New York, next to the Navy Yard, and I'm here to meet our corporate member Qunnect on Quantum Day, 14th of April. I am with the Chief Science Officer of Qunnect, Mehdi Nemasi. Mehdi, what's happening today?
Awesome. Today we have a lot of exciting things. Not only we are expanding our R&D and research facility in the heart of New York, Brooklyn Navy Yard, to more than 6,000 square feet of space. We're also launching our Gotham Q quantum testbed officially. For the first time ever here in New York, we have a fully functional testbed of distributing quantum entangled photons, which you can literally see it live on the monitor right now, and the experiment is right behind me, that we are sending very high purity, high rate entangled photons in the fibers in New York City, the fibers that are going to Brooklyn, to Queens for 35 kilometers and coming back here. And we show that we can preserve high rate, we can preserve high fidelity with a very uptime of the network, bringing this entanglement distribution much more closer to practical applications in metropolitan scales.
This is the first quantum network of its kind in the United States.
There are a lot of firsts, and all these networks, like everyone is doing something differently, so it's very fair to call all of them first, but this is truly the first time that we are very practically distributing very useful entangled photons that are generated to be very compatible not only with telecom infrastructure, but also with different quantum devices, quantum computers, quantum memories, quantum sensors, so we can go beyond the basic application of quantum networking, which is the quantum encryption and key distribution, and go towards this dream of quantum internet, distributed computing and sensing.
In addition, today is a very important day for Qunnect. You are launching a new product, the Q-Source. What's the Q-Source?
Yes, we are launching this guy sitting right here. This is the quantum entanglement source that we have been building in the past few years or so. We just put a paper on this on arXiv. You can go read the details of it. But it's the first of its kind atomic quantum entanglement source. So there are a vapor cell filled with atoms of rubidium is sitting there. We excite these atoms with two different lasers, and as a result, the atoms gives us a pair of entangled photons. This is a very unique device because it gives you so many characteristics that you really need for a scalable quantum network. Not only this device can generate more than 10 million pairs of entangled photons per second with very high fidelity, it also generates photons that are all naturally sub-gigahertz line width, much better for interfacing with different quantum devices. On top of that, this is a bichromatic entanglement source. This source generates a pair of photons that are polarisation entangled with each other. One is at telecom wavelength, the other one is at near IR wavelength. This is the device that can bridge the gap between the telecom preferred wavelength and the wavelength that is dominantly preferred by atomic devices, which is always in the near IR regime.
This produces exceptionally pure polarisation photon pairs. How will this scale?
Well, hopefully it scales in this direction. We make it smaller, we make it multiplex. This is a very simple, robust device. That's the part that really matters about this. This is fully room temperature, vapor cell. Right now, literally everything that is sitting on this device is off the shelf, but of course our future plans is to do these things on much more smaller scales, much more multiplex, so we can bring these rates even much higher than this is, and hopefully even one day have all these devices on chip, so you can have something that is smaller than your cell phone and it's generating you millions of pairs of entangled photons per second.
Optica corporate members want to help you, from photonic integration all the way to nonlinear crystals to specialty fibers. How can other Optica corporate members help the success story of Qunnect?
Well, you named a few examples. There are a lot of things we need help with. We are a team of 15 full-time employees right now, and like every other startups, every team member here is doing like 6 things at the same time. And these entanglement sources, as you can see, It is very robust, it works for long term, very stable, but we are still in the stage of prototyping. We want to go towards manufacturing. We want to go towards scalability of being able to build these devices, hundreds of them, if not thousands of them, with very cost-efficient ways, and like they all work the same parameters, so we can reliably integrate them into the telecom infrastructure, leave them for like 5 years, 10 years, and forget about them, because that's the standard telecom needs. So there is a lot of things, if you guys reach out to us, we know that needs to get better, but right now our bandwidth, our team capacity doesn't allow us to go there, which we could totally use your help for.
There is 100 people coming to visit Qunnect today. Why is everyone so excited?
I mean, I'm very excited. This is a very exciting day anyway because this is the quantum day. This is the day. And every year this is getting more exciting because every day people are like launching new products, new events. This is the first time here that we actually have an operational testbed in New York City. This is not a testbed that works for an hour or so. Like the data that you're seeing on the screen, it always shows the past 12 hours or so, but I see from yesterday 3 p.m., sorry, the past 24 hours, I can see the data of entanglement distribution from yesterday 3 p.m. till now, and a network that we have been distributing with an uptime of 99.95% right now. So this is getting very close to a 24/7 test bed of distributing high purity entangled photons for a lot of applications. So it's getting very exciting because now in New York, you could be walking and you're literally walking on a fiber that is carrying high purity entangled particles.
We are in one of the economic centers in the world. This is where Wall Street is. How do you see banks? How do you see the banking industry benefiting from what Qunnect is doing?
Yeah, so there is one very known application for quantum entanglement distribution and its role with distributing secure keys. QKD, quantum encryption, these things are very, very common and already been deployed everywhere in the world. But the problem with the QKD is that it lacks a lot of scalabilities that you would need for a larger scale network. Using entanglement is really, if not the purest way you actually could share a secret key between two parties or even multiple parties, and you make sure that only you know. And the very good part about using entanglement to do secret key exchange is that we could be generating the entangled photons here. We could send the photons to, for example, different branches of a bank or something, and they don't even need to trust us whatsoever. This is a true untrusted node. Could be anyone here because entanglement has this power that you can independently verify whether your network is secure or not.
So we've been doing a lot of progress on our products. We have a commercial quantum memory now. We have an entanglement source that's compatible with a quantum memory and compatible with other quantum systems. And we want to start working with partners that can then install this on their test beds, use this as part of their research. And we want to expand that community that's working with warm atom systems for the scalability of the quantum networks. So we're opening a branch in the Netherlands. We're working with some partners there already. We're working with other partners in France and in Germany to really start deploying these technologies in the field and doing large-scale quantum demonstrations. So we're very excited about opening the branch and start these collaborations. We want to bring some of what we've been demoing here in New York in Europe and kickstart that and move the whole field forward altogether.